everybody. Let's go over a solution to the type of thinking that you need for this kind of problem, which is about our convolution algorithm. Just to remind you, the idea of a convolution is you're going to do a process for every 3x3 region in an entire image. And so here's an example for a 3x3 region that's centered at, it looks like row maybe 5, column 6. What the process is we're going to multiply corresponding elements. So we're going to access element 0, 0 from the kernel and multiply it by the upper left-hand corner of the 3x3 region. But then we want to access the next column over in the kernel and multiply it by the next column over in the image. The next column over times the next column over, and so on. So we're multiplying each of these pairs. And that's what makes the problem tricky. It's because when we're accessing the kernel on this line, whatever we use for the indices have to visit indices 0 to 2 always, because the kernel is only a 3x3 2D array. But in the image, where we're accessing in the image depends on where we're starting. So here I say RC represents the center of the 3x3 region, and you see R is here and C is there. So if we've got a row here and a column here, as the kernel values are going from 0 to 2, we want the image values to be going from row minus 1, so the row above where the center is, up to row plus 1. And so they have to move together. So what you need to use is the indices kind of depends on what values we've set up the variables to loop over. So here I notice that row goes from 0 to 2, which is perfectly set up to loop over the kernel. So because I noticed that, I see that these can be used for the kernel without any adjustment at all. I don't need to add or subtract anything. I couldn't use row and column here in the image because that would mean from the image I'm accessing indices 0 through 2, which would be up here. But I don't always want to be looping over the upper left-hand corner of the image. I want to be looping over a region that's centered at RC. I also know I can't just have R and C here, because if you remember the way nested loops work, R and C never change value until we make it back up here. So we're busily looping over all the values of row and col here, all this loop. And meanwhile, R and C are not changing. So if I kept this as just R and C, I would be visiting each location in the kernel, but I'd be multiplying it by the exact same location in the image. So the image locations wouldn't be moving. Okay, well, I see that, let's try one more thing. So let's say R plus row, C plus col. This doesn't quite work either. And a good way of testing to see if it makes sense is by imagining what value is it going to give you the first time you go through the loop. So rather than imagining R is 1 and C is 1, let's imagine that R is, let's see, 0, 1, 2, 3, 4, 5. Let's say R is 5 and C is 0, 1, 2, 3, 4, 5, 6. Okay, so we're imagining that R is 5 and C is 6. When I enter this loop, row is 0 and col is 0. So I'm accessing the kernel value that's at 0, 0. So that's the upper left-hand corner of the kernel value. Okay, so now I want to think about what location do I want to be accessing from the image, and then I'll check to see, does this actually give me that location? So because row is 0 and col is 0, I'm accessing upper left-hand corner here, so I want to be accessing the upper left-hand corner there. Let's see if I'm actually doing that. So I said R was 5, so that takes me down to 5, and then plus row is 0. So that means I'm accessing this row. So I know that the row is 1 too large. And C takes me to the center column, and then col is 0, so I'm actually accessing this location. So it's like I am shifted down by 1 row over by 1 column from where I wish that I was. So if I adjust it by subtracting 1, now here I've got R minus 1 plus row and R minus 1 plus column. And you can go back through with some numbers and double check. Geometrically, it also makes sense if you think about it this way. R and C point to the middle element, but I want to loop over my 3 by 3 region starting at the upper left-hand corner. So if I say r minus 1, that takes me from the middle row up 1. C minus 1 takes me from that middle column over 1. So the r minus 1, c minus 1 adjusts my starting point so that I'm starting from the upper left-hand corner. Once I'm starting from the upper left-hand corner, when I add row and column are always a value between 0 and 2. So I'm starting at the upper left, and I'm adding a number between 0, which wouldn't change it at all, and 2, which would take me all the way down to the bottom row or all the way over to the last column. So it's some very detailed thinking, and you can think about it numerically, or you can think about it geometrically as where in the image we're actually accessing. It's helpful to be able to do both, and it's nice to be able to check using individual values and ask, what do I want it to be accessing, and then is it actually accessing that location? Let's do the last part here. So I'm supposed to be outputting, or I'm supposed to be taking the output and assigning it in a new image in the very center of the 3 by 3 region that I've just looped over. Well, because R and C represent the center of the 3 by 3 region, I can just use R and C. Okay, let's try another one. Okay, in this version, it's the same situation, only this time R and C and row and col are defined differently. So now now R and C represent the upper left-hand corner of the 3 by 3 region. So that would be R, and this would be C, representing the upper left-hand corner. And row and col don't loop over 0 to 2 anymore. Well, I know that row and col have to be about the kernel. And the reason I know that is because I've already defined R and C up here as the 3 by 3 region in the image. So if row and col are supposed to be about the kernel, I need them to only loop over indices 0 to 2. Right now, let's look and see what they seem to be looping over. So right now, if row is 5, if R is 5 and C is 6, row is going to start at that 5, and it's going to go up to a value that's smaller than 8. So let's imagine it. So it's going to start at 5, and then 6, and then 7, and then it's going to stop. So it looks like R is going to loop, so it looks like row is going to loop over these 3 indices. And we can remember that for a minute from now, because that's exactly what we want to loop over in the 3 by 3 image. We want to start here and end there, and that's what row is doing. Same thing for col. Col is starting at C, which is there at the starting value, and we're looping up to the starting column plus 3. So we're starting at 6, and we'll go 7, 8, and then we'll stop. So row and column have been perfectly set up to visit the locations in the image that we want, but they're not very good for accessing the kernel. So what do we have to do to access the kernel? Here's a nice way of thinking about it. In the kernel, we want to be accessing 0 to 2. That would be the same as if we were accessing indices kind of up here. So imagine taking the values of row and column, but then shifting them up until they're at 0 and left until they're at 0. So if I take row, but I subtract that initial R, and I have column, but I subtract that initial C. And you can test it with numbers to make sure it makes sense. So let's pretend that R is 5 and C is 6 up here in this loop. So row is going to start off equaling 5. Where are we going to access in the kernel? We're going to access row, which started off as 5, but now we're going to subtract that initial 5 to get 0, which is where we'd want to be. Same thing for col. And then as row increases, let's say row is now, let's say we've added 1 to row. So row was initially 5, but we've added 1 to be 6. So that means that we are now in the middle of our 3 by 3 region. We would want to be multiplying by row 1 in the kernel. So since row was initially 5 and we added 1 to make it 6, if we subtract R, which right now is 5, 6 minus 5 is 1, and that's taken us to the correct spot. So as you can see, you gotta have in your mind what's the process that you want to see, and you have to be able to keep track of all the indices separately in your mind. Okay, so far so good. Now at the bottom here, we want to be taking the output and storing it inside of the center index of the 3x3 subregion. But right now, R and C represent the upper left-hand corner. So here's R and C. So we have to adjust them to output to where we want, which is just one row down and one column over. So we take R and add 1, and C and add 1, and now we're outputting to the center. So that would be an example of the kind of thinking you do for the second problem. Hope this helped.